All right, everybody. So we're getting ready for the IB math exam coming up very soon. And one of the questions that we were looking at is a paper three style question. And paper three, remember, it's going to ask you about stuff that you haven't really seen before. And it's going to break the question down into lots of different subparts. And you have to use the information to try to get back on track. It'll give you lots of hints. And there might be a point where you get stuck and you just have to cut your losses and try the next section and try the next section because it usually gives you part of the result to show. So just keep that in mind strategically when you're actually doing the test, that it's okay to get stuck and then just pick up on the next section. They usually give you a re-entry point. So anyway, the question they're asking us to look at, and I'm only going to do part of it because I don't want this to be a 30-minute long video, is looking at functions, cubic functions that look like this: x cubed plus 3 or minus 3cx, and then plus d. And so you can see that as the c value changes, we're changing our x-intercepts, we're changing the number of x-intercepts, we're also changing, I guess, the stretch of it. Let's get it back to whatever there. And then the d value shouldn't be too surprising. The d value is just sliding the y-intercept up and down, which can change the number of x-intercepts. So there are some combinations of C and D that have 3 x-intercepts, some that would have only 2, and then some that have only 1. So the specific questions that somebody asked me about were looking at given some information. So what if we are given this information? So given that f has exactly 1 local max and 1 local min. And we are asked to figure something else. So figure out something about the C value. Okay. So if I want to find a maximum and a minimum, I'm going to take a derivative. So my original function is called f of x. My derivative is fairly straightforward, 3x squared minus 3c. And if I'm going to find a maximum or a minimum, I'm going to set that equal to 0. I'm going to solve for x by adding 3c, dividing by 3, and getting x equals, not c equals, x equals plus or minus the square root of c. Okay? And I can figure out if it is a maximum or a minimum by taking the second derivative. So this right here was finding f prime. If I find f double prime, it's positive 6x. So f double prime of the positive square root of c is 6 times the positive square root of c, which is bigger than 0. If the second derivative is bigger than 0, then that means that we are concave up and we found a minimum. If, however, the second derivative is negative, like what will happen when I plug in negative root c, then we know we have a concave down and we have a maximum. So therefore, we know that if we plug in the square root of c, we'll get a minimum. And if we plug in negative square root of c, we'll get a maximum. And what do we plug them into? We plug them into the original function. That's how we get a y value. So the y value of our minimum is going to be f of the square root of c. In other words, the square root of c cubed minus 3c square root of c plus d. Okay? And if you work that out, the square root of c cubed is the same as c times root c. We can use 2 of them to cancel the square root. The only reason I'm doing that is just to combine my like terms. This is 1 copy of c root c, and this is minus 3 copies. So I have negative 2 c root c plus d. You could write that in a slightly different way. You could say that's negative 2 c to the 3 halves, because you have 3 copies of the square root of c plus d. And so if I go over here and test that formula out, negative 2c raised to the 1.5 plus d, and then I check the value of my minimum, you can see that those two answers agree with each other perfectly, the y values. Okay, and they actually continue to agree with each other. Ooh, I guess if I have a negative c value, oh yeah, because I'm taking the square root. If I have a negative c value, then that point does not exist. And so, but you can see that if I change the c value, my formula still works to give me the y coordinate of the maximum, or the minimum, excuse me, and then the y coordinate of the maximum is almost the same. It just has a positive 2 in front instead because of the symmetry. Okay, so then we're looking at, if we're looking at positive c values, and what I want you to notice is when we had a negative c value, there were no local min or max because the local min or max required us to take the square root of c. So we can't take the square root of a negative number if we're going to get a real valued function. And we're talking about the graph of a real function here. Okay, so what else are we looking at? So now it asks us to think, hence, if c is positive, okay, so c is positive, meaning we do have a local minimum and a local maximum. We want to talk about when will it have exactly one x-intercept, exactly two x-intercepts, and exactly three x-intercepts. And what that does is that depends on the value of d. Okay? So what we know is that I'll just look at the minimum, for example. If the local minimum is negative, then I know that there's going to be a 0 before the minimum on the left side, before the maximum, a 0 in between the minimum and the maximum, and a 0 after the maximum. If the local minimum is equal to 0, like that, then I will only have two x-intercepts. And if the local minimum is bigger than 0, I will only have one x-intercept. In other words, the only thing I really need to look at is how does, I guess, what is the y value of the local minimum? Or equivalently, I could do this with the y value of the local maximum, and I can figure out what values we can determine from there. So I didn't explain that perfectly well, but what I'm going to do is I'm going to look at this, and I'm going to set it equal to 0, because that's going to tell me the break-even point. So if I set that equal to 0, then I get that d, and I add that over, equals 2c to the 3 over 2. So if d is equal to 2c to the 3 halves, then my local minimum will equal 0. Okay? If I try to make my local minimum's y value be bigger than 0, I need d to be bigger than 2c to the 3 halves. And if I do it less than, then I would have 3. So let's look at that example there. If I want to calculate 2c raised to the 3 halves, then what I can do is copy that number and put it as my d value, and I will get a graph that only has two x-intercepts. If I make my d value bigger than that, now I only have one x-intercept, and if I make my d value smaller than that, I have three x-intercepts. However, I also need to worry about the other value, the maximum. And so I can do the same thing for the maximum, because if I make my d value too small, then I pull the maximum down below as well. Okay, so let's play the same game, and I'm going to create a little bit more space here. So let's do this. Let's clear the whole screen. Okay, so what I have is that my if d equals 2c to the 3 halves, then my local min is equal to 0. And that also implies that there are two x-intercepts. If d is bigger than 2c to the 3 halves, the local min is greater than 0, and that implies there are 3 x-intercepts. Let's look at the other side of things with the local maximum. So we get a local maximum by plugging in negative square root of c. So the local maximum, we would say negative root c cubed minus 3c negative root c plus d. This looks very similar to before. This is negative c root c, and this is positive 3c root c plus d. So we get almost the same thing, positive 2c root c plus d. And so then the other possibility is that d could equal negative 2 square root 2. And what that would do is if I make d equal to negative 2 c square root, oh, oops, it's not square root 2, it's square root of c, excuse me, square root of c. If I make d equal that negative value, then what's going to happen to my graph, and you'll be able to see this in just a second, is that, oops, my graph symmetrically, so it only hits there. So we have a very similar idea here that if d equals negative 2c root 3 over, or c to the 3 halves power, then that means my local max equals 0, and that also implies 2 x-intercepts. And then similarly, that if d is bigger than that value, so if I slide my d value up at all, then I get 3. So local max is bigger than 0, I get 3 x-intercepts. I think I must have written something backwards before, because I'm looking at my answer and I'm looking at what I wrote up here, and I think that this inequality is written backwards, because I need, for there to be 3 x-intercepts, I need this d value to be smaller than 2 root c to make my minimum smaller than 0 to get 3 x-intercepts. So sorry, I think maybe I said the right thing, or I just wrote the wrong thing. I think I was backwards. The point that I'm trying to get at is there is a range of d values that in between negative 2 roots 3 over, in between negative 2c to the 3 halves and positive 2c to the 3 halves, I can't talk today, in between negative 2c to the 3 halves and positive 2c to the 3 halves, you're going to have 3 x-intercepts. If d gets bigger than 2c to the 3 halves, then you will have 1 x-intercept. And if c gets smaller than negative 2c to the 3 halves, you will also have 1 x-intercept. So those are the only ways that you will get 1 x-intercept. So let me summarize that, and I'll try to write it in correctly this time. So let's use purple for the correct thing here. So if I want there to be 1 x-intercept, then there's 2 possibilities. D could be bigger than 2c to the 3 halves, or d could be smaller than negative 2c to the 3 halves. If there's going to be 2 x-intercepts, then I need either d to equal 2c to the 3 halves or d to equal negative 2c to the 3 halves. And if there are 3 x-intercepts, I need it to be in between those 2 values. I didn't give myself enough space. So in between those 2 values, meaning that negative 2c to the 3 halves is less than d, and d is less than positive 2c to the 3 halves. Okay, so I got a little twisted around there for a second, but I hope that makes sense and helps out with how you can approach this problem. Remember also on paper 3, you can use your calculator to visualize what's going on. So let me know if you have any questions, and I'm happy to help.